this video we are going to prove that limit of e raised to x minus 1 upon x as x approaches 0 is equal to 1. Now, in order to prove that, we use the following series. Now, we know that e raised to x could be expressed as 1 plus x square upon 2 factorial plus x cube upon 3 factorial and so on. So now let us begin with the left hand side. Now left hand side is equal to limit as x approaches 0, and the function here is e raised to x minus 1 divided by x. Now we simply replace e raised to x by the series on the right hand side, right? So we obtain limit as x approaches 0. Now we replace e raised to x by 1 plus x square by 2 factorial plus x cube by 3 factorial and so on minus 1, the whole thing divided by x. Now if you open the brackets, now 1 would get cancelled with minus 1 and we are left with, I'll just erase these two. So cancelling 1 and minus 1, we are left with limit as x approaches 0. Terms left are x plus x square upon 2 factorial plus x cube by 3 factorial and so on divided by x. Now if you observe, we could take x as the common factor in the numerator. So taking x as the common factor in the numerator, we obtain limit as x approaches 0. So taking x common, we have 1 plus x by 2 factorial plus x square by 3 factorial and so on divided by x. Now we could simply cancel x in the numerator and x in the denominator. Reason being, x is approaching 0 and hence x is not equal to 0. So what we are left is, so the left out part is limit as x approaches 0 of 1 plus x upon 2 factorial plus x square upon 3 factorial and so on. And now we could substitute the value of x as 0, that is the approaching value of x, which is 0. Finally we have 1 plus, now 0 divided by 2 factorial would be 0. The third term, that is x square by 3 factorial, this would also be 0. So all the remaining terms which contain x, right, will be 0. So our final answer is equal to 1 and that is equal to the right hand side.